All right, it is my pleasure to introduce our next presenter, Julie Wolfe. Julie is Conservator of Decorative Arts and Sculpture at the J. Paul Getty Museum. Julie has a BFA in Art History from the University of Illinois in Champaign-Urbana. What is it about Illinois today? I'm not sure. She obtained a MA from Buffalo State College, specializing in objects conservation and advanced training at the Harvard University Art Museums. Her conservation work prior to the Getty includes the Harvard Cornell excavation in Sardis, Turkey, the Williamstown Art Conservation Center, and the Solomon R. Guggenheim Museum in New York. She is currently a conservator at the J. Paul Getty Museum in Decorative Arts and has been there in sculpture and has been there for 14 years now. Her research has focused on fill materials for marble sculptures, the electrochemical cleaning of metal objects, and more recently, conservation techniques for outdoor sculpture. The Getty Museum acquired an outdoor sculpture collection in 2005 and took a lead role in planning for its long-term stewardship, worked closely with the living artists, and initiated research on materials and techniques for ongoing maintenance. Along with her department colleagues, she co-authored a book in 2010 called Conserving Outdoor Sculpture, the Start Collection at the Getty Center. She is currently writing a book on Roy Lichtenstein's outdoor sculpture, the artist's materials and techniques. Julie?
Okay, thank you. It's really a pleasure to be here today. I've learned so much already. That's okay. You good? Okay, good. The organizers have really done a brilliant job at organizing this program and choosing a great range of diversity of topics. I first learned about the technique of carbon dioxide blasting in 2011 when Richard Wolvers came to the Getty and gave a talk, and it inspired me. And ever since then, I've been playing around with the technique. And I'll be candid, and I'll say I don't feel like an expert at all. I still feel like a novice. But working with the technique, I've generated a lot of ideas and made some explorations for which I really thank the Lunder Conservation Center for inviting me and for organizing this to provide kind of an avenue for discussion. So carbon dioxide blastings is really a great tool. I have a crush on it right now. I love to find new ways to use it. It's an EPA-approved cleaning system, and while it puts back recycled CO2 into the air, it doesn't produce CO2. And it has, being an alternative, for me anyway, to chemical cleaning, it has the benefits of reducing VOC emissions. So the technique of using carbon dioxide blasting is remarkably straightforward and controllable, and has the flexibility by using different systems and parameters. And my experience is strictly with pellet and block ice blasting, so in particular regarding coating removal for outdoor sculpture at the Getty Museum. And I've also been using it for cleaning, corrosion removal, and also for when I'm doing coating testing for kind of surface cleaning for projects like that. So I want to go through some recent projects, pretty much chronologically, and focus on the overall treatment planning and how CO2 was kind of pieced into that process. So I'm going to spend less time on the specifics of the parameters, like what PSI, what mass feed, but really kind of focus on the question of not how, but really what is it that we're trying to remove, and how do we figure out what we're doing. So on that premise, I'll start with the treatment of, of Roy Lichtenstein's 3 brushstrokes. Many of you may have heard about this project that I did in 2011. I've given a talk at a conference, and there's actually a post-print of that conference, and my treatment is described in detail, so I'm not going to go over a lot of it today, and just refer you to that if you have more questions. But when we acquired this sculpture, it had been overpainted, and the paint was failing. There were corrosion pustules, blanching of the paint, it was flaking, and it was really clear, again described in my paper, that the entire paint system had to be stripped and repainted. And carbon dioxide blasting was obviously considered as a possible technique. So what we did is we moved the sculpture outdoors and created a tent around it in order to do a system of treatment where we used paint strippers in combination with carbon dioxide blasting. And I had never done the blasting before, and I felt I wanted to take a bit of a conservative approach and hire someone who had experience, and so I contracted out the work to somebody who also subcontracted to a lead abatement company, because unfortunately there was a lot of lead paint and chromium-based paints. And so obviously we needed to carefully dispose of the paint once it was removed. So I did do a lot of testing. It's out of the range of this presentation of different paint strippers. And we found that a peel-away system, number 7, manufactured by Dumont, worked very well. And so the first step was to apply the paint stripper, let it sit for a couple of hours, and then we used the carbon dioxide blasting using a pellet instrument. The one that was used is a cold jet IRA40. I'm not sure if this is still manufactured. It's an old instrument. And it uses rice pellets that you can buy, and we also rented a special compressor as well with filtration. That was an instrument that we used. So the first run of the carbon dioxide blasting, most of the paint was removed, the red and the yellow and the blue, black, but not all of it. And actually I can show, this is a video, so let me see if that will run. Does it? It looks a little dark from up here, but it was a little bit slow. I think they ended up using quite high pressure. That, at the time, it was hard for me to gauge, what's the limit. They were using up to about 130 PSI. They switched the nozzles to try and optimize the paint removing. And, I did have some concerns about, applying pressure on the surface and of aluminum. It's about a 1/4-inch thick sheet that's been fabricated and welded. So there was concern about the structure and the surface. But that was also one of the reasons why I combined the paint strippers with it. I was hoping that by softening it with the paint, with the chemical cleaners, that we could use a lower PSI. So this is just a day after doing that, and so we had to reapply some more of the paint stripper to soften the rest of the paint, and then eventually after the next day all of it was removed. In retrospect, and this is something that someone brought up in the past, that there's an issue of a redeposition, and I found that working in that environment, they're at that pressure, lots of paint stripper, lots of paint. And it kind of went everywhere. And so I do feel like there was a bit of redeposition on the surface. So after the company cleaned, basically scrubbed the tent in order to dispose of the waste, and the tent was brought away, I felt like it had a little bit of a film on it. And that made me a bit uncomfortable prior to repainting. So at the time, we did do some steam cleaning to clean it. If I were to do it again, I would have gone back in with carbon dioxide blasting, because in retrospect, probably introducing the water to the surface was not the best surface prep prior to cleaning. But we did test several different paint strippers, and I did want to briefly mention that using chemical strippers in combination with carbon dioxide is one possibility. I know it's not eliminating the VOC, but for this particular object that had such thick epoxy and polyurethane layers, it was to me, it felt necessary. But just one concern, I kind of really pushed the boundaries and tested different coupons, and I noticed that some of the strippers were etching the surface and some were not. So, that's another thing to consider. Maybe with higher PSI, we would have gotten some damage to the aluminum, but with more chemical exposure, we would have also gotten the same. So that's just another thing that I'm also exploring and I'm doing more research on. And I have to show some before and afters because it was a really successful treatment. And just the artist assistant actually came out and did the repainting for us at the Getty. So that was a really wonderful experience. And also I want to mention very candidly that how you strip a surface prior to repainting could affect the adhesion. One concern I have now is the use of just chemical strippers and then repainting. When we repainted recently our Calder jousters, it was contracted work, and the painters used a chemical stripper, cleared with acetone, and then reprimed and repainted. And unfortunately, I mean, it's a complicated process, lots of different parts and components bolted together. It's really hard to get a good, secure paint layer. And we already, after 6 months, we're starting to see some rust. It wasn't just on the bolts, but on the plates as well. And I just think that we've talked to a lot of different paint chemists and just, manufacturers, and it kind of boils down to surface preparation and that the surface wasn't fully cleaned. And had we used carbon dioxide blasting, we probably would have gotten a better coat. So our next project is going to be a Calder again, a little more complicated ethically because it was originally black and it's now red. So we have that whole aspect to tackle and figure out. But I imagine that we probably will use carbon dioxide blasting for this treatment. I also use it just as surface prep, not to remove paint. So this is a sculpture by Robert Adams that has a mild steel base painted with polyurethane. And periodically, it just needs to be repainted. People step on it all the time. And rather than having to fully strip and repaint, I can just sand down the surface a little bit and then use the carbon dioxide blasting as a surface prep prior to adding another coat. So one of the major treatments that we did at the Getty in 2013, I believe, is the Henry Moore bronze form. It's kind of the larger of the sculptures that we have at the Getty. And we did, because our staff was low at that time, we did contract out the work to get some help on this. And so I want to thank John Griswold and associates who worked on this with us. This sculpture had a polyurethane clear coat, and it was 20 years old, and as you can see from the pits on the surface, that it was starting to fail, and it was just time to remove it and reapply. And I'm not going to go through the discussion in detail about the treatment, but really just focus on our approach using the carbon dioxide blasting. I like to make coupons before we do, just for testing, just to get comfortable with our surfaces. So I patinated some bronze using a ferric nitrate, which is what bronze form had, and then coated with polyurethane and tested different strippers to see how they reacted. And then made some other observations that, for example, the peel away on the left completely stripped the ferric nitrate patina. So it's just something, always test before you use anything. But it's just nice to kind of play around with these materials and get comfortable on, again, what your limitations are. And there were some proprietary and actually homemade strippers that we tested that did remove. But again, we wanted to use the carbon dioxide to facilitate the removal and to also clean before recoating. This project was done in situ, and we built a tent around it with lots of ventilation, and we rented a MicroClean, an i3 MicroClean, which uses the block, and Rosalind has described that system very well. In this case, we purchased a pellet form of carbon dioxide, and then using a kind of a block maker, you can actually make blocks to use for the MicroClean. So the treatment was done inside the tent, and applying, I believe it was safe strip, they applied first for about 15 minutes and then used the carbon dioxide to clear it. So on the bottom, you can see where all the coating has been removed. On the top, there's still some polyurethane. And it was a very kind of clean process. And so, and it was recoated with Incralac, but it was a very successful treatment. The The larger project that I'm engaged with right now is kind of a 5-year plan at the Getty, where all of the bronzes, outdoor bronzes in our collection that have Incralac on them need to be recoated. So the Incralac on all of our bronzes is at least 20 years old, and it's done a great job. It's protected the surfaces, but now they're all pretty much at the same time starting to fail. And so I had to kind of quickly come up with a program for getting all of them done pretty quickly. So I gave myself 5 years, which is not enough, but I gave myself 5 years to try and figure out how to get them all treated. And the idea of using solvents to remove the Incralac and all the waste just did not appeal to me at all. So I do know when we worked on the bronze form, I had a lot of coupons made up with Incralac, aged Incralac, and I was able to remove it without any chemicals, and just on coupons. And so that gave me the idea that, well, I think it's possible. I'm sure that if we use carbon dioxide, we can find a way to make it work. So I did the number crunching, and actually it would have been cheaper to buy a unit than to rent it for all those 14 treatments. And they're not cheap. The MicroCleans are about $23,000 to $29,000. But I calculated that if I rented it for $1,500 a week for all of those treatments, it would have been much more than that, almost $40,000. So I actually was able to convince our administration to buy it, and it's the best purchase I think we've ever made in our department. So we use it quite frequently, and I really like it. It's a heavy unit. I mean, it's somewhat portable. Rosalind's already explained how the block is used. What I liked about it is I felt like it was a middle ground between, the snow and then the pellet blasting. From what I've read, the block is a little bit more, kind of more controlled, a little bit finer, and you can use pellet blasting basically, from what I've read, is a little bit more aggressive, and Jim's probably going to say something differently, which is fine, but from what I had read and researched, that's what I had understood. And I like that you can kind of control the flow, and I had some other things I wanted to say about it, but let's see. Yeah, but basically, shaving the blocks, you're getting kind of more consistent shape and an more even clean, apparently. And so we also wanted to, and let me show you that when I say that you can get a little bit less aggression, you can buy these instruments where you actually pour in the pellets, and then it compresses it, and it creates a block that you can then use in the i3. And it's an expensive piece of equipment, so you wouldn't really buy it. But what I've heard, you can rent them, but what I've heard is that, exactly, safety. It was cold. Yeah, so what I've heard is that when you make your blocks from pellets, you actually get a little bit more aggressiveness, and we actually tested it out. And I encourage anybody who buys a unit or even rents a unit to get technicians out and just make them bring you things like different nozzles, and because you learn so much from just testing things out. And we did find that if we bought a solid block versus made one from pellets, there was a difference in aggressiveness. I also wanted to do all of the treatments indoors in our walk-in spray booth. The booth is supplied with compressed air already, and the problem is that it was constructed, it's not a problem, but it was constructed to a fire code, and it's explosion proof, and we weren't allowed to put the instrument inside the room and use it because of the motor. So I'm not recommending that people do this because it has some, there are pros and cons to this, but I felt like it was important to be doing these treatments in a controlled environment. So we kind of worked with the manufacturer and our facilities department, and we actually rewired things and kind of ran all the hosing through the wall. So you can see it coming, it's outside of the spray booth here, and then on the right, the hose is coming through, and your nozzle is there, and we're using a foot pedal. So we've kind of modified the system a little bit. You can just open up the back, and then just we pulled out the trigger line, and we attached a foot pedal. And again, just with safety, we We use gloves, thermal resistant gloves. We have been wearing respirators regardless, because you really don't know what you're removing. And in the case of working on bronzes, if there is some corrosion removed, breathing in copper corrosion products is very unhealthy. So we really want to avoid that. We wear ear protection because it can be very loud. And we also monitor our carbon dioxide levels using a meter. And once the alarm goes off, we take a break. And we find that working in a small spray booth, though, we haven't had a lot of problem because of the ventilation of the, of the air draft going. So our first treatment is from this whole kind of 5-year plan was done a couple years ago. It's by Aristide Maillot Tour-Stolete. And it's a beautiful, small, almost life-size sculpture that has a golden brown, beautiful potassium chromate patina. It's coated with increlac and wax. And so our approach was first to see if we can just use carbon dioxide blasting. And I should say this is a project that I worked with my colleague and Brianna Feston, who's here today. And she and I worked on this project together, and then I left for sabbatical for 5 months, and she finished it up. But it's a good example. I want to show this. It's a good example of our kind of first treatment and attempt at using CO2. We've been taking a really conservative approach. So we used the carbon dioxide blasting to a point where we could easily remove the wax. But we knew, and that's through doing some scientific analysis, that we're still increlac underneath. And by pushing the PSI and the feed rate, we felt like it was a little bit too risky in affecting the potassium chromate patina. So we went from removing the wax using carbon dioxide blasting to then, and this video is not going to work, so I'm going to just move on. But we use the carbon dioxide blasting to remove the wax, and actually one useful tool is just to look at your surface under UV after cleaning, because you can see on the bottom of the circle that that's an area where the wax was stripped after blasting. And increlac doesn't really fluoresce, so it's a good way of kind of distinguishing what you're doing a little bit. And we use solvents, kind of acetone and acetone mixtures to remove the increlac. And I wanted to bring up the point that what we're really starting to see is, and it's kind of obvious, but it's worth just saying, that the aged coatings on outdoor bronzes are really, they're not homogeneous, and there's a lot of kind of blending in of the waxes, or wax and increlac even, that happens just through regular maintenance. So, one cleaning technique doesn't seem to be working for the entire surface. So, we were able to get down to a certain level, or Brianna was able to get down to a certain level, but we didn't really seem to remove all of the coating. I think there was some wax that was under the increlac that was left over. And in order to get rid of that, we felt we'd had to really be more aggressive, and didn't feel it was worth it at that time. So we kind of just recoated and kind of toned in a little bit to even out the surface. But it was still a very successful treatment, and I think it's a stable coating of increlac, which is a whole other talk in itself on choosing which coating to use to recoat, but we are recoating with increlac. So the more recent project that we have done is a Barbara Hepworth called Figure for Landscape, a larger bronze. And I worked on this project with another colleague, Christina Sims, who's also here today. She's great. And this sculpture arrived, as you see on the left, at the Getty Museum when we acquired it in this condition. And we have some archival photos of how it looked to the previous owner, Ray Stark, very splotchy. So we know that there's been, a lot of coatings applied, and there is increlac and waxes. So based on what we learned from the Tour Stolete, I wanted to sort of see if we can kind of go, analyze layer by layer a little bit better, and working first with, I'm going to try and skip this, yes. First with taking cross sections and seeing if we can kind of identify what layers and what we're dealing with. Cross sections didn't really work so well. Mounting them, it's kind of, we did not end up getting all of the representative layers. So we did take a different approach for sampling, and we would take a top layer, which you can see it's kind of a yellow crusty layer, took a sample, analyzed it with FTIR, and found an ester wax. And then, but under UV, you could see that that wax was fluorescing white. So once I sampled that, you could see an area that didn't fluoresce. And so I cleaned the area that was fluorescing white and removed it based on UV using a Formula 83 as just a hydrocarbon blend. We analyzed again that layer, and it was increlac. So then I cleaned with acetone, thinking I'd remove the increlac. And there seemed to be something else that showed up that was fluorescing kind of an orangish color. And so we sampled that, and then we found an ester wax. So again, that's not something that I really expected. It makes complete sense now, but often you'll have a wax coating put on at the foundry, and then somebody will put an increlac on top of that, and then we wax on top of that for maintenance. So, we have really kind of 3 layers here, and that's really going to affect, our system that we choose for cleaning. So we started off by testing using the carbon dioxide blasting just to remove the wax. Well, that was what we expected we would get. And in order to preserve the chemical patination, probably a cupric nitrate, which was pretty well bound, we didn't want to use too much pressure, and we really wanted to preserve that. So we just did the carbon dioxide blasting to remove we have a video, I'll start that, just to remove the wax layer. And then we did a little bit more analysis, and we were able to see that there was increlac still underneath. Then we used a solvent acetone cleaning to remove the increlac. And I wanted to show the video to show you about the speed and we used kind of a wide fan, fairly unaggressive nozzle. And so this is us pulling the sculpture out of the spray booth, and there's still some blotchiness that we kind of looked under the microscope, and it came up with xylene, and we identified it as the wax. So what was left over was that wax that we were finding in our sampling scheme. So rinsing with xylene, then we were able to get rid of that and really get a nice, beautifully preserved patina. And also in retrospect, I think Christina would agree that we would probably like to try carbon dioxide blasting to remove the wax in this case. But I also know that in past experiences that the wax that's on the surface of the metal can be really, that if it's really oxidized, it can be, you might need to be a little bit more aggressive. And so we wanted to really avoid being aggressive on the patina. And so here's a picture of it before and after treatment. Okay, so should I wrap up or show one more quick? It's a great video. So we bought the MicroClean, and it was sitting in our lab, and I was all just excited and kind of getting it all set up in our spray booth, and we didn't have any bronzes yet. But we were in the middle of my colleague Arlen Hegenbotham and Jan Dorscheid were working on the restoration of a tall clock case by lots. And there are hundreds of these gilt bronze mounts. They were all disassembled, they all had corrosion, and they all had cellulose nitrate coatings that were failing, so that was causing the corrosion. And I thought, well, let's see if we can get the cellulose nitrate off with the CO2, and we tested it, and sadly, it didn't remove the cellulose nitrate, but it did remove the corrosion. So that's kind of an interesting, and we could have, really played around with some more. We had extreme time limits. And so we just used the carbon dioxide blasting for removing the corrosion. It was so fast, and it saved hours. And I mean, cleaning gilt metals is so tricky, and no one likes to use chemicals. So if we can use something like this, that would be really great. But I do want to do some more research on it, and with some coupons, because I don't know how it's affecting the gilding. And so it didn't seem to be, and so anyway, so that is that. I just want to thank everyone. And one person I did not mention is Hrant Kanjian, our scientist at GCI, who did all the analysis for us. So thank you very much.
Does anyone have a pressing question for Julie, or you want to wait until, you can also wait until the roundtable? We've got one here. If you can use a mic, please.
Yeah, sorry, I went over.
Julie, just very quickly, was the cellulose nitrate film acting as a mask so that the dry ice blasting was just cleaning the corrosion where it had failed?
I think so. Yeah, because it wasn't removing the coating, and I mean, the corrosion is where it had penetrated, through the gilding and the coating. So yeah, I think that it was acting as a mask, which is also a really interesting phenomena. And it, the idea of maybe being able to, remove one layer and not another, there's so much potential with that idea, so. Okay.
Do you think CO2 snow could take off that stuff off the gilded surface?
The gilded?
Yeah.
I don't know. And I've never used snow, and I'm, dying to try it. But I'm not sure. Yeah. It was a kind of a high pressure that we were using there, so, it was 20 PSI. So I don't know. I'm not sure.
Great, thank you. Thank you very much. I hope you're all getting the theme of you have to kind of try it until you really know. I'm delighted to introduce our next presenter. Siska Genbrugge is an objects conservator at the Royal Museum of Central Africa in Turven, Belgium. Previously, she worked at the Los Angeles County Museum of Art as an assistant objects conservator. She began her career at LACMA upon completion of the UCLA Getty Conservation Program, where she graduated in conservation of archaeological and ethnographic materials as a Fulbright scholar. Prior to that, Siska studied metal conservation at the University of Amsterdam and earned an MA degree in art history from Katholiek University Leuven in Belgium. I'm sorry for butchering that. My apologies. She will be presenting in Dutch, so keep your ears open. Just kidding. During her conservation studies, she also completed internships at Athenaeum Agora in Greece, the Royal Museum of Central Africa, again in Belgium, the British Museum in the UK, and the Museu Nacional de Arqueologia in Portugal, and Luxor Temple in Egypt. Siska?
Hi, everybody. I would just like to thank you and everybody at the Smithsonian Institution for inviting me to this wonderful conference, and I would like to excuse myself for my voice because I'm losing my voice. So I hope you guys can understand me. Yeah. There you go. So my name is Siska Genbrugge, and I'm currently an objects conservator at the Royal Museum of Central Africa in Belgium, but I'm here today to present to you a treatment which I carried out with objects conservation people at the Los Angeles County Museum of Art back in the spring of 2012. At that time, I was working as an assistant conservator, and the project that I'm presenting here is essentially a group project, so it's not only me that carried out the project, it's also my colleagues, Silvio Boario, Natasha Cochran. So I just wanted to say that this was essentially a group project. So with my colleagues Silvio Boario, Natasha Cochran, Lily Dwan, and John Herx. So on this slide you see the outline of my presentation that I'm going to give today. So after a short introduction to the object, which is a sculpture called Saddle by Anthony Cairo, I will briefly give you an overview of its conservation history. Then I will discuss with you the state of the object before its treatment in 2012, which was pretty interesting. Then we had multiple treatment options, but after convincing demonstration session of a dry ice cleaning company and careful deliberation about the results, I decided to clean the object with solid carbon dioxide pellets. The outcome of the treatment will be discussed, and I will briefly mention future treatment steps for this sculpture, although I'm not anymore, no longer at LACMA, of course. So we are moving to the Los Angeles County Museum of Art. In 1991, the former director, Powell, decided to create a sculpture garden at the east end of the campus, which you see here. There is the east side of the campus. It's a kind of a weird card, but anyway. So it's just behind the Japanese pavilion. You have amazing sculptures there, like the Donald Judd that you see, the Lieberman, and also the amazing Fountain of Calder, the Hello Girls, which was made for LACMA, the opening of LACMA. So, and amongst these gems stands the Anthony Caro, the saddle. I don't know. Yeah, I'm just going to continue, okay? So LACMA's current director, Michael Govan, decided he has a strong focus on modern and contemporary art, and he wanted that sculpture garden to be kind of revived for the opening of the Calder show in 2014 and LACMA's 50th birthday, which is this year. So he started looking at the Calder, at the saddle of Anthony Caro, which was, by the way, donated by Eli Broad and his wife Edith Broad, who are major donors, so it's a pretty important piece. So when he saw the Calder, it became very clear that it was in dire need of treatment. The front of the sculpture had these weird patches of different purple hazes and multiple bird droppings, and strange corrosion, especially near the bottom part of the sculpture. A saddle is a special sculpture because it's just a low carbon steel, so it's not a corten steel. So it's a very mild carbon, but you can easily like shape and form, and it's easy to be welded. But on the other hand, it corrodes quite fast, and yeah, it doesn't make a passivating corrosion layer, so it kind of needs a coating if you put it outdoors. And even the front looks still pretty okay, but if you look at the back, then you know what I'm talking about when I say it's in dire need of treatment. There were large rectangular patches that you see here. I mean, I don't have to point them out, I guess. And here, that look very strange. And when I started the research for the treatment of a sculpture, I quickly began to realize that I was not the first person that took on the challenge of treating this sculpture. There was a giant binder, really a giant binder, bulging with information in the conservation office. And I was able to create a short timeline of all the information that I could find. It was kind of little notes and weird MSDS sheets from strange products, but I could figure out these things. So the sculpture was made in 1976 by Anthony Caro, as I mentioned. It was donated to LACMA in 1980. And in 1982, the first signs of degradation started showing, so the conservators back at LACMA decided to contact the artist's studio and ask whether they had a good coating for the object. And they received a letter back which stated that Val oil, which is a linseed soy ester gum with alkyd resin, suspended in aliphatic hydrocarbons, was the best option. So they applied the layer in 1983. And then they never took the layers off, so they just coated on top of it. As Julie said, you often have this problem that coatings are put on top of other coatings, and everybody's kind of too lazy to take them off because it's nasty work. So what happened was in 1993, I got another report stating that the object was in really, really bad condition, and that on top of that, they added more waxes and shellac. But I'm not sure what they meant with shellac, so I'm not really sure if it was really shellac. So in 1999, back then the conservator decided to start a major treatment. And the coatings were removed with zip strip, which is a paint stripper based on methylene chloride. And the steel plates were all detached from each other and re-welded with bead welding technique, so the water could be easily drained in between the plates. The conservator back then also started to have questions about the val oil. And so communications with other institutions as the Hirschhorn Sculpture Garden and the Natural Gallery of Art showed that the val oil coating was not performing well. It left a buildup over time, and it was very difficult to remove, and it became brittle and prone to delamination during exposure to the sunlight. So that's not at all good. On top of that, in 1999, also the use of val oil was forbidden in the state of California due to the high amount of VOCs. So the conservators started looking for new coatings, and they decided to try 3 different commercial coatings. The first one was the McEvoy satin spar marine varnish, then also the Proline, and also the Penetrol. So we briefly this morning mentioned the Penetrol, so you will also see some of that. So images of these coatings were taken. They were applied on the sculpture, the coatings, on different parts of the sculptures, and then an image was taken, and that was sent to the studio. And then the studio picked the one they liked most, and that was the marine spar. Subsequently, 2 layers of marine spar were applied onto the sculpture. And in 2008, the conservators decided to create multiple large test squares. So that were the squares that you saw on the back of the sculpture, and to try out new coatings. But unfortunately, these squares were never coated with new coating. So what happened was they started re-corroding, and that's why you have these bright orange squares on the back of the sculpture. It's just kind of a shame. So together with our back then intern, Lily Dwan, we decided to do a thorough visual inspection and a UV inspection of the sculpture. And our main observations were that there was an overall cool blue-yellow fluorescence. And then we also could discover all the old areas of the test coatings from 1999. So here I say where you have the Proline, and then here was the marine spar, and here was the Penetrol. So you really clearly saw it under UV light, that they were still there, and also even under visible light you could kind of see all the different coatings. And only the back squares, they didn't fluoresce. These squares didn't fluoresce. So a closer look at the coating. Here you see 2 close-up pictures of the coating. So you have this multiple layers, I call it coating, but it's kind of a buildup of coatings, multiple layers of coatings that were very badly applied. And you see here on the bottom some brush strokes. Then here you see some chunks of old coating that was then mixed with new coating that was reapplied. So it looked pretty bad. And then you have this kind of hazy, kind of water stains, I think. I'm not really sure what they were, but they also made it look very ugly. In some areas, the coating was, I could measure the coating, it was about 1/16 of an inch thick. So here you see also there was water damage and the corrosion. The water went underneath some of the coating, under the thick coating, and the corrosion made the metals falling off. So you had really quite large pieces. It's kind of a shame that I didn't put a measuring tape there. Quite large pieces of sculpture kind of detaching. And then you had the regular stuff like bird droppings and footsteps of people walking on the sculpture. So I think it's kind of clear that the sculpture was not in good condition. So the 6 main challenges for this treatment were how to remove different layers of coating that we don't really know what they are in one technique. And indeed, as Julie said, it's kind of impossible, but I wanted to try it anyway. Have a treatment that was gentle enough to keep most of the iron corrosion, because as you know, iron is really hard, but the corrosion on top of it can be very fluffy and loose. So you have this tricky thing that you have like this hard metal, and then you have this porous, loose corrosion that is penetrated with like this horrible coating. So it was kind of difficult to find a good treatment for that. And then also the treatment had to be carried out in Los Angeles weather, which is hot, sunny, and dry. Not as hot and sunny as Arizona, but still quite hot and sunny. And then we, of course, like always, had a tight time frame and tight budget. And I wanted to be as environmental as possible, environmental safe as possible. So we tried to do some solvent tests, and they were kind of disappointing. So what we did is we only used the marine spar varnish because that was the latest varnish that was put on the sculpture. So we coated some test panels of steel, milled steel, low carbon steel, with 2 layers of the marine spar varnish, and we let it dry and then put it in a UV chamber for a couple of days. And then we decided to do little swabbing tests with solvents. And the result was pretty, yeah, as I said, not so good. Only acetone, so fast evaporating solvents or very toxic solvents could remove the coating. And then I started looking into other mechanical cleaning options. And all the options that I found, you have a lot of waste material. The object is also in a park, you cannot move it, so it was kind of problematic. Then we had to build a tent around it, which would take a lot of work. So I wasn't really convinced. But that's when I remembered that my colleague Rosemarijn van der Molen, she carried out a treatment of solid carbon dioxide, and so I decided to look into that. And I think I'm gonna just quickly go over this slide because I think you guys heard this already, that of course it's mainly the mechanical effect, it's the blasting effect of the carbon dioxide that does most of the work. But I also found that the thermal effect for my treatment was quite, it really helped a lot to cool down that layer, that coating. But I will go further into that a bit later. So the advantage of this method, the cleaning method of carbon dioxide, is of course that it sublimates immediately, so you don't have any waste residue. And if you think about other, like pellet cleaning, walnut cleaning or something, and walnut shell cleaning, you have a lot of waste material. So this is definitely one of the biggest advantages. And of course, it's environmental friendly, which was also on my list, because it's made of repurposed carbon dioxide. So I decided to contact several dry ice cleaning companies in the LA area, and I received several offers. And Hailstorm, I made some advertisement for them. They really were keen on helping us, and they decided to organize a demonstration session for the conservation department. And so with the article of Rosemarijn in mind, I really wanted to test the i3 jet, which you see here, which is the shaved ice blasting. So we again made some panels. Lily did them. Here is Lily done. And so we coated them and aged them. And then, yeah, we went to the guy. And we coated them also with a layer of wax. And then we tried to test it with the i3, and it didn't do anything. So we were very disappointed, of course. But we also had a rubber project back then, and we were trying to do research on the degradation of natural rubber. And you see here our Mr. Rubber, or degraded rubber, and who had a nice smiley face also with a Sharpie, made with Sharpie. So, and we tried to blast that, and that gave really amazing results without affecting the Sharpie. But that was just a little side joke. So here you see the guys. They also brought another instrument, which was the IRA40. So it's one size bigger than Julie's IRA30. And that was a huge machine. And the guy was a bit crude. And coarsely, as you see, he put his foot on our pallet and then blasted it. And we were all blown away. And yeah, the result was very good. So the coating came off immediately. And then our scientist, Frank Preußer, looked at it with his little loop to see how much corrosion product, because of course you also remove iron oxide corrosion product. So how much corrosion product was removed, and it seemed that it was pretty okay. Back then they used 100 psi to blast that, and they were really close to the layer. So that was a really harsh way of cleaning the layer. But all by all, we were convinced of the pellet blasting. So the first machine that you saw, the i3, was the shaved ice, and this one was, of course, the pellet blasting. So we were convinced to take the pallet blasting to rent a machine. And we decided to rent the lowest machine, so the least power and the smallest container. And that was for us the Coldjet IRA4. And it also has a container of, I thought it was 30 pounds. Yeah, 30 pounds dry ice capacity. So it can, the container can hold 30 pounds of dry ice pellets. The pellets we had was also the 3 millimeter pellets. So nowadays there's also pellets that are smaller, up to 1 millimeter pellets. So, but back then you could only choose 3 millimeter pellets. There's some other specific things about this machine, and that's that it has a vibration of the hopper, because dry ice pellets, they tend to clog. If you leave them too long in the sun, they become like one big hard block. So you have to shake them, and there's an internal shaker that keeps the pellets from clogging together. The pellets arrive in big containers of 500 pounds. They're these blue insulated containers. But so, unfortunately, the containers, they don't last long. So after 2 days, you really notice that the quality of your pellets goes really down because of the melting and because of the clogging. So it's best to repurchase every day new dry ice. So you have to have somebody close by who can deliver you the dry ice. So that's, I think, is a big cost and a bit of a hassle, is the delivery of the dry ice with the dry ice pellets. So the machine itself, it has variable functions, which I really liked, and that's the one is the feeding of the snow. So here you see that little button, you can feed the snow, so you can have less or more pellets that come out of the machine. And then, of course, there's a range between 20 and 140 psi of pressure. So what was very important to us was also the variety in the nozzles, which was also already mentioned. So you have the variety of the pressure, you have the variety of the feeding of the dry ice, and you have the variety of the nozzles. And these are the 3 nozzles that we, in the end, used most. And we had this type of hose. So you have 2 types of hose for pellets dry ice cleaning. I thought it would already have been explained, but it's not. So I'm just going quickly over this. The single hose technology, it was pioneered by Coldjet in 1986. And a single hose system, there's one hose that is loading from the machine to the applicator, and there is a feeder system that feeds the dry ice particles and compressed air into that single hose. So the dry ice particles are then accelerated by the compressed air stream through the entire length of the hose, so it has a lot of time to accelerate. And so that's why it becomes also a bit more aggressive technique than when you only add the dry ice pellets near the end. Then you have a shorter time to accelerate. So this is a less aggressive technique. But the advantage of the single hose is that you can have a much longer hose, which was necessary for us because we had to go around the sculpture. So you have to also think about the necessity of like cleaning and being able to go around it. And a second advantage is that you can blow upward with your nozzle. So with this double hose, you cannot blow upward with your nozzle. So, and for us, because we had to go under the sculpture, it was also pretty important. But if you have more questions about these 2, I can always explain it later. So this was our setup. You have the compressor, you have the dry ice pellets, and you have to feed the dry ice pellets into our Coldjet. Then you have your big hose, your applicator, and your nozzle. And here you see Silvio working. He was not wearing goggles, but not for long, because after 1 day, you really feel like the blast. So he started wearing goggles. You also need earplugs. It's a really high pitching noise from the blasting, and on top of that you have this giant diesel compressor next to you the whole day, so it's definitely not an easy work environment. So per day we used about 2 containers of 500 pounds of dry ice pellets, and it was quite hard work, I would say. So what we did, we split up in 2 teams of 2. One person would feed the machine, and the other person would blast. So these slides show you our team doing the dry ice blasting. In total, we blasted about for 6.5 days, which is quite long. I initially thought that it would last 5 days, but with the introduction, and as Hugh already mentioned, it has a learning curve, so by the time everybody got the hang of it, it's also pretty heavy. You feel the pressure of the machine, so it's not easy to learn it. So it takes a little while. I would say it takes at least half a day per person to learn how to handle the machine and to know what the right distance is. Like here you see that I'm very close to the sculpture. Sometimes I was further from the sculpture. So you really have to feel what's the best position for you. So, so as I mentioned, we used 2 containers of dry ice, so about 1,000 pounds a day. And they were delivered fresh every day. So in total, we used 12 containers of dry ice. So for the whole project, we ended up using 6,029 pounds of dry ice. So it sounds like a lot, but you go through it quite fast. And the total rental and the dry ice, everything, it costed less than $5,600. So we were quite on budget with that. So for most of the sculpture, we use a pressure between 60 and 80 psi, so quite high, combined with a medium particle feed and the long, narrow nozzle, which you see here. So this nozzle turned out to be the best for us. And here you see really the before and the after. You see that we blast through a lot of the corrosion layer, and you really go to a lot of the because also some areas were easier to go through than others, and you often get to the bare metal, but we didn't really have an option because cleaning the corrosion layer with solvents would have I don't know how much solvents we would have needed, but a lot. And this was really, in the end, a clean technique, and we could take all the coating off. So I was very happy about that. The only parts where we couldn't get the coating off were the bottom parts and the parts in between, like here, the back part of that panel, we couldn't reach, so we had to do some further solvent tests, of course. And so for these solvent tests, my colleague and I, Lily, we did it, in fact, before the treatment already of the dry ice treatment, we already did some solvent tests. And we figured out that just like Julie also mentioned, that some paint strippers were our best option. So we used the Smart Strip, which turned out okay for the job. We used about 2 of these buckets. And so we applied it, and then we rinsed it with hot water, and then we rinsed it with a power wash. And the good thing was that there was no difference between the blasting and what we took off. So you didn't have a difference in corrosion appearance. So it was about the same appearance, which was great, because one of my concerns with the dry ice cleaning was that I would have like streaks of where I blasted or patterns in the blasting, but there was none of that. So I was very happy about that. So here you can see again the sculpture before treatment, and this was a sculpture after treatment. So in the end, it turned out really nicely, except for here you see where the proline coating was. That coating must have gotten into really the corrosion layer and had a very strong bond. So it really, I couldn't remove that coating. So you really had like darker, that area and this area, and then on the backside there was also an area where you have a darker coating. Unfortunately, the backside was much harder because you had these large squares that were already re-corroded, but in the end, I could kind of make it more even, and I'm really sorry for this bad picture, but I couldn't find another picture, but you really have a more even corrosion layer, and now, a year later, the sculpture is still not coated, and you really have already better integration of the two parts. So the future, to coat or not to coat these sculptures, it's a very tricky question because you have that powdery corrosion layer, and if you ever want to remove that coating, you really have to damage your corrosion layer. And so I leave this question for you guys, if you can give me an answer, or at least some advice on whether or not you think this is a good object to coat. Personally, I think that this object would best go inside, indoors, because Anthony Caro wasn't, he was an outdoor sculptor, but in the beginning, like in the 70s, he also made sculptures for indoors. And because this is just a steel sculpture and not a corten steel sculpture, I think it's a valid proposal to maybe put it indoors. I mean, LACMA has a Serra indoors, so maybe there's some more space for Anthony Caro. So just give me 1 second. I'm missing a slide here. Okay, so the answer to my initial challenges for this treatment, the dry ice blasting could remove the thick layers of different coating, except for the proline, as you saw. The blasting was gentle enough to keep some of the corrosion, but unfortunately, a lot of the corrosion was lost. So that's something that you really have to keep in mind. The treatment did remove the coating evenly without streaks or patterns. And unlike other solvent cleanings, dry ice cleaning is the ideal treatment to be carried out in Los Angeles weather, because solvents, they evaporate so fast. You have to do it only in the morning in the wintertime. So for me, in Los Angeles, that was definitely a good treatment. And the fact that it was environmental friendly was definitely also a plus. The negative points, as I mentioned, is we lost some of the corrosion layer. There's a big learning curve. There's also the pressure, because you rent the machine, so you have to do it that week, and you have to be able to like gather everybody together, and you have to blast it, and it's heavy work, so you cannot do it by yourself. You have to have a team to do it, or you have to rent it out. And of course, it's as environmental as possible. So these are the sources that I used. And I would like to thank the following people. I would like to thank especially Yossi Voselov for his pictures, and Silvio, who's here in the audience, for helping me with this project. And of course, also the Royal Museum for Central Africa for letting me come to this conference. Thank you so much.
Thank you very much, Siska. Hope that was food for thought for everyone. We'll hold questions until the panel discussion. Next up, our last speaker of the afternoon and of the conference for today, Jim Gwinner, who is coming to us from McKay Lodge. Jim is a conservator of sculpture and public art at McKay Lodge Conservation Laboratory based in Oberlin, Ohio. Jim's background is very diverse. He actually comes from a BA in painting and sculpture, dual focus from San Jose State University. Jim is an experienced fabricator, maker of a wide variety of materials. He's provided fabrication services for a select group of artists, living artists, Harry Powers, David Middlebrook, Gwen Merle, and Michael Todd. As a conservator of sculpture of public art, Jim manages projects and researches materials, preservation materials and methods, and performs conservation treatments. And I would say that Jim's work is all over this city. I know that McKay Lodge, specifically Jim being involved in projects for GSA, has brought him here quite often. He's especially skilled and knowledgeable in metals fabrication, metal art, maintenance and repair, and I would argue that Jim is probably one of the best urethane acrylic painters out there these days. He's had quite a bit of experience working in plastics-based outdoor sculptures from a number of projects I've seen from him before. Jim?
First of all, thank you everybody for having me, and thanks for all the other speakers. We've seen a lot of applications for what I would consider micro applications. Most of ours are macro applications. So we're dealing with really large sculpture in hard to reach places with a variety of different substrates. So the reason we started looking into CO2 was we were increasingly being called on to meet the EPA guideline of the Clean Water Act. What that basically states is that you can't have any water runoff. As you can imagine, if you're cleaning a monumental sculpture, you've got a lot of water to deal with if you're dealing with pressurized water. Setting up of tarps and pumps and collection tanks became quite tedious, and I didn't like it anymore. And basically wanted to find another process where I could kind of avoid all that setup. So we started looking at CO2 cleaning. We found it was environmentally safe. That's been covered. It's non-flammable. It's non-conductive. By that I mean electrically conductive. Non-abrasive, which we've seen some information to the contrary on that, but in our case it's been very, very non-abrasive. Non-corrosive, I put an asterisk there because if you get condensation, water can be corrosive. But for the most part, the works that we're cleaning, it's not an issue. One of the big aspects is the fact that there's little to no preparation. I don't have to set up barriers. I don't have to set up any special protections or collection. And we found that to be very, very cost effective. And of course, there's no waste to clean up after the fact. In comparison to solvent cleaning, we have no swelling. We have no harmful or toxic chemicals or compounds. They're not spread by runoff. No expected hazardous compounds created with combinations of solvents. I always like thinking of the baking soda and vinegar thing I did when I was a kid. No collection of solvent runoff, no pickup of disposable of cleaning solvents, and no fire hazard. In comparison to water blasting, which we used to use quite frequently, we have no drying time, no water damage to electronic parts, again, no swelling, no harmful toxic chemicals, no runoff, and as an added benefit, bacteria and fungi are actually killed by this process. So if you're utilizing this on stone, it works quite well because it actually kills all your biologicals. Occasionally, sandblasting is called for, media blasting. Again, this process is non-abrasive, so it doesn't grind the surface down or leave a surface profile. The coating on the surface can be preserved. I can actually be gentle enough to leave paint or labels undisturbed. Soft parts are unharmed. This means things like caulking, areas like that. I don't have to worry about masking these areas off because this process doesn't affect them. And disassembly or masking to prevent abrasion is not necessary. So if you're dealing with things like kinetic sculpture, I don't have to tape off, say, bearing surfaces or surfaces where grit could get into and damage sculpture. And again, no pickup or disposal of the grit. So what's it take to run this process? Well, we're kind of a bigger industrial version, so we need a fairly large compressor. This is the one that we use. It's got a minimum of 175 or 185 CFM and 100 to 250 PSI in pressure. Compressors are basically heat generators, and as they compress air, they generate heat. Heat condensates. The problem with, and we've heard this before in the talk, is that dry ice doesn't like water. You have to get rid of the water out of the system. We use a pretty large dryer, and what this does is this is about 25 feet away from the compressor. That allows the air to cool down before it hits the dryer. The dryer essentially separates the water. The clean, dry air is now sent to the compressor. This is absolutely vital. If you don't have this, basically you get clumping, it'll be very hard in operation, and we've heard what water does to CO2 before. This is our blasting machine. It has a holding capacity of 44 pounds. It can shoot out 36 to 122 pounds in an hour. So it can really throw out some ice. Supply pressure, 72 to 232 PSI. And we have a minimum of 29 to 145. And then the air consumption rates are 25 to 175. I stole this slide, I think, from the last presentation, so this is awesome. I like to consider this working on 3 different effects, and we've had this discussed already, but there's basically the kinetic energy. This is what I like to think of as the pellet's actually impacting the surface and what that can do. That turn feeds the thermal kinetic effect, which is basically the pellet sublimating. As they do that, they expand upwards of, say, 700 times their size. So you get these kind of mini shocks to the system. And then you get the thermal shock, which can cause embrittlement of coatings. So we found that these are kind of the three primary actions happening. As you start to experiment with CO2, you kind of have to figure out which one of these three effects is working. And then you can adjust your setup to capitalize on that. And I'll go through that a little bit later. I wanted to just touch on nozzle selection, because we've seen nozzle selection, but our nozzle selection is large. We have different size orifices from 6 millimeter to 10 millimeter. We have a diffuser, we have a funnel, and we have a straight nozzle. So as you can see, when you're setting this process up, there's quite a few variables just in the nozzle selection. I can't tell you that this nozzle is more aggressive than this one, because in some cases, this one's more aggressive than that one. Again, it kind of reaches back to which one of those effects is causing the cleaning action, and then you adjust your nozzle setup. You can actually pass it around. So the first thing I used it on was a Luis Jimenez piece called Los Lagardos. The piece had a failed clear coating over an automotive paint. What was happening was the clear coat had failed, was causing severe degradation to the underlying base coat. So to recoat this, we had to remove that top coat. You can see how bad it was. Faced with having to use a scalpel for like a year, I figured there had to be a better way. So this is actually the reason why we bought this machine. So I started testing with dry ice, and I was able to surgically remove the harder top coat from the softer base coat. It had to do with technique, but as you can see, it was quite effective at removing that hardened top coat and leaving the softer base coat behind. So I was pretty happy about that. That took me 3 days to do the whole sculpture. We've heard some discussion on how it works on duplex coatings. This is us cleaning the Thinker at the Cleveland Museum of Art. This is a photo showing the clean surface on the left, the old coatings on the right. You'll see a white part line, and those are both coatings being removed at the same time. Again, clean surface on the right, unclean surface on the left. And I think I have to was actually true. It essentially took us 3 hours to clean that artwork. And we didn't have any kind of external media to clean up, and at that point we re-hot waxed the sculpture, and it just came out beautiful. There we go. So now our next case study was the Veterans Memorial in Charleston, West Virginia. This is quite a large monument. It has 4 life-size sculptures of Army personnel from the different wars of the 20th century. This was the condition. We had a failed clear coat. It was blanching and cleaving from the surface. So we went out and did a test, and at the top you can see the failed coating. The middle band is the removal after dry ice, and on the bottom is the new coating that we applied. And this is what it looked like about 5 hours later with the new coating applied. So we were actually able to treat this monument in 3 days. So in comparison to solvent cleaning, that would have taken quite a bit longer. Next up is the cleaning of aluminum sculpture. We had 12 of these guys from the office of the EPA. They had been coated in shellac, furniture polish, wax, nicotine and cigar smoke, you name it, it was on there. And so we actually tried to solvent clean these, but it was so resistant and so laborious that we decided to try dry ice because, hey, we've got this machine, right? Let's give it a shot. This is a close-up of the surface. This is a clean surface on the right, the dirty surface on the left. And as you can see, we're not adding any profile to the surface. So we felt it was safe enough to proceed. And the white stuff on the ground is actually snow. I did this in the middle of winter and not dry ice. So. And here's some shots of during cleaning, kind of the removal of the grime. Next up, we had an orrery, and I love orreries, but this one had been coated with epoxy on the iron legs, and I think it was to kind of adhere the paint that was becoming quite friable. So our task was to get this epoxy off and leave this kind of friable, unstable paint coating underneath it. It was a hard resinous substance. I'm not exactly sure if it was epoxy, but it was very, very resistant to solvent cleaning. So again, we tried dry ice, and we found the effects were just great. Let's see if this video will run. Okay, next up, we have a bronze fountain located in Ogden, Utah that hasn't been treated probably since the 70s. It has an insane amount of mineral deposits, algae growth, and it's quite disfigured. The patina that's basically there is no longer viable or representative of what the artist wanted. You can see how thick some of these mineral deposits are. And I have another movie. Now this movie will show you how aggressive dry ice can actually be. So up until now, we've been running at, say, a maximum of 125 PSI. In some cases, our delivery had varied from, say, 33 pounds an hour to 70 pounds an hour. This next video will show you And of course, the benefits of that are we don't have any media to clean up. We don't have to tent the whole sculpture, which in this case is quite large. And on the right is that same area after blasting for just a few, probably 45 seconds in real time. So we've seen how gentle it can be, and I was actually very surprised at this. It can actually be quite aggressive. Everybody's favorite, graffiti on Corten. It's been the nemesis of my life. I actually did the graffiti on this piece. This is a piece that needs repair, and luckily enough, we're going to remove this piece entirely. So I felt, you know, pretty able to kind of do what I wanted to it. And I have a video of that as well. So what we noticed was after I cleaned that, actually the corrosion, you know, like Corten, it's usually very active. Within a few days, it basically kind of returned to the same look, and we had very, very little ghosting. So as far as treatment goes, I found that this was a pretty viable alternative to, say, maybe hot water blasting. With hot water blasting, I found that sometimes you don't get the complete coating off, and you'll get residue. The last case was an asphaltum paint on brass railing. This is for the Armory in New York City. This coating was very, very thick, and if you tried to solvent clean this, you're going to go through a lot of rags and a lot of solvent. I managed to clean this with solid CO2. I just wanted to point out the condensation on the smaller parts. And I managed to clean all 3 of these railings in 45 minutes. Again, with no surface damage to the brass. And that's it. Thank you to the other presenters, Continental Carbonic, and the listed institutions. Thank you.
Thank you very much, Jim. I'm going to have to add a budget line for symphony accompaniment to treatments, I think. I don't know about you, but I'm stoked. So let's have our afternoon panel and open it up for questions. If you'll wait until somebody will get to you with a microphone so we can get the questions recorded, that would be great.
Yeah, I'd love to come out and do it. It'd be great. Thank you. Pretty basic.
This is a question.
All right, Joe.
This is a question for not only this panel, but the group or the other presenters in general. I was wondering if anybody's done testing to evaluate the effectiveness of CO2 blasting for removing soluble salts on the surface. So comparing it to sort of NACE standards, SSPC standards for contamination of surfaces prior to coating application.
We haven't as of yet, but I know that in industry, say Ford Motor Company uses this to prep all their vehicles now before coating. And so I would imagine any kind of soluble salt just would leave the surface very, very easily. I have done this on stone. I didn't show it, but limestone deposits and mineral deposits just disappear.
Sorry, and I had one follow-up regarding a coating system for that Caro sculpture.
Oh, yeah, thank you.
I was just wondering if you had considered using corrosion inhibitors. They have sort of alkaline washes with corrosion inhibitors added that would last, especially in an LA environment, probably once a year, maybe once every 6 months.
Would they alter the appearance of the piece?
No,
A lot?
no,
Okay.
they would leave it.
Because
essentially.
the artist was very concerned it had to look velvety. That was his main concern. So as long as we find something that is velvety and keeps the look. So maybe I have to look into corrosion inhibitors.
You'd get your velvet, I think. It
Okay.
shouldn't alter the appearance at all.
Okay.
What is the toxicity of these
Yes.
types of conversions?
No, they're
I've looked
just,
into them.
a lot of them are soy-based products. Cortec Corporation makes a lot of these. They're completely environmentally friendly. So it's a way that we deal with a lot of complex things where coating systems are susceptible to failure because of wear points and so forth.
Yeah.
That we treat them then with corrosion inhibitors and just the client can apply it themselves actually. A lot of it just through a simple garden spray or bug sprayer.
Sounds wonderful. Thank you.
Other questions? Got one over here.
Yes, when you say that there was no damage to the substrate, was that damage with your eyes or with a hand lens,
No.
microscope, SEM?
Actually, we didn't do SEM, but we did look at it with a hand lens, and we noticed no surface profile changes at all. It might be on a microscopic level, but typically an outdoor sculpture that would be acceptable over the alternative of media blasting of some sort to remove a patina.
Okay, thank you.
Oh, just since I'm nearby. I have a follow-up on Judy's question, which is, how is it, Julia, that you, when you were doing the same process, did find that you were losing the patina and Jim wasn't losing the patina, as you both were using pellets, if I understood correctly?
I actually had the same question for Jim because, and we are using different instruments. And so and as we have said all day, depending on what your parameters are and what nozzle you're using, you can get a tremendous difference in performance. And so, we have been playing around with the MicroClean with different nozzles and pressure, and we haven't found that, comfort zone. And, I just don't have as much experience, actually, as Jim, and so I'm still working on it. And I'm hoping to find a way to do these treatments where I can use the CO2 for all of the stripping, because it would save a lot of time. And so actually, it was a question I was going to ask Jim. Do you think I could, using the MicroClean, remove more than I have been?
Yeah, I think there's a wide range of patinas, and any one that is properly applied with heat by a patineur, I find to be quite stable. If it's a very friable, powdery kind of patina, you're going to eradicate it from the surface immediately. But typically, an artistically applied patina from a foundry, I believe, is going to be quite stable. And we've done tests in the lab where I've patinated coupons and had no effect on the patina at all. So I think a lot of it has to do with the quality of the application of the patina. So it's something you'd have to ascertain as you go up to the sculpture, and take a hard look at that patina and think, well, is this going to do? And of course, as always, we do very, very tiny test areas for stability.
I had a second question, again, in terms of the technical modification of the materials. If I understood correctly, it's felt that the snow is the least abrasive, and then comes the shaving from the blocks, and last, or hardest, the pellets. So is there a sort of a Mohs hardness scale that these are being measured on, or?
Like was stated earlier, it's all the same material. So basically, the shaved block has the same hardness that the pellet does. I think primarily what it is how hard is that pellet being propelled to the surface. If I crank the machine up to 232 psi, I can take paint off of anything. But if I leave it at 35 psi using the same ice delivery, it's not going to affect it at all.
And does the shape have any effect?
It can. In the case that I'm passing around, there's an item called a diffuser, and basically in that diffuser is a small screen that can break the pellets up into smaller particles. In some cases, that makes it more aggressive. In other cases, that makes it less aggressive. And again, it just depends on which of those three factors that you're dealing with. So if the thermal effect is what's causing it mostly, more impacts per square inch, meaning a smaller particle, is probably going to have a greater effectiveness.
And then this is maybe extraneous, so how would you all say this method of cleaning would be compared to laser cleaning?
I don't have any experience with laser, so I can't answer that.
I mean, I don't either. I've never used it. I haven't been trained to use it, but I have heard from other outdoor conservators who use lasers outdoors for this sort of thing, and it sounds like it can be comparable, but I really don't, I'm not in a position to.
I would just interject that one of the things with the solid CO2 cleaning that's actually a limitation with lasers that it overcomes is it doesn't matter in terms of the degree of contrast in your substrate. So you've got an optical quality that you have to take into account in terms of parameter for laser cleaning. Here you're taking in just, it's more a material aspect that you're really looking at for the parameters. So we had another question over here.
It's on the laser cleaning.
Okay.
That essentially you cannot have a cuprite corrosion layer try to remove a clear coating from the top without going down to you cannot remove a green corrosion layer, sulfate layer, without going down to a cupric or cuprite. So you would turn it brown. It works well on brown sculptures in removing coatings, but if you're trying to remove it from a green sculpture or another patinated surface, it does go down to cuprite.
Thanks, Joe. Question here?
Yes, my sculpture conservator has been bugging me to get into the water-based cold patinas. And I'm just wondering if you had an experience with trying to clean those.
Yeah, I actually experimented with that with some of those. I typically see those mostly as dyes and not really as a proper patination. But they are quite stable under this process. The brass railings that you saw are going to be treated with a cold patina, and just for entertainment, I went ahead and cleaned those, and it was fine. It didn't affect it at all.
Question here in the center.
My question is regarding paint removal on 1930s steel casement windows in the middle of a city. It sounds like this is a great opportunity to not have to deal with the setup that you need for chemical or water or any of that. Is it pretty successful on paint removal?
In my experience, yes. That being said, it's, again, a trial and error basis. It depends on the coating entirely. You have better success if the coating has already kind of failed. So if it's starting to cleave and you have fractures in it, then absolutely it's going to take it right off. If it's well adhered epoxy coating, probably will have no effect on it.
But test for lead first.
Yes.
That changes everything.
Yes.
And has anybody used a direct, you've talked about extractors, but can you sort of set up a good exhaust system so you could use something like that may be lead-based in a public area? Any experience that way?
Well, I'm not trained in lead abatement, but I think it's a little more complicated because you really have to do conversions, and there's a scrubbing process where you can't just throw out your lead waste. I think there's a treatment that you have to do with it, and so it wouldn't be that straightforward.
I was just wondering if there was a collection system anybody had run into.
No.
Not really. I've run into the use of products or surfactants, and actually I've also run into chemical strippers that are designed for lead paints, like the Pretox 8000 that I tested. I tested it because it was designed for lead, because it does some sort of conversion, and that way you can then more safely dispose of it. But
Rosemarin, did you have a comment?
Yeah, I just wanted to add something to that question. This wasn't particularly for lead, I don't think, but the cold jet, they showed me they had a nozzle which blasts and then it also sucks, so it would take away the whatever you were blasting off, and they had been using that for asbestos. But I don't actually know. Maybe someone else knows.
that would be great.
It's
I don't
having
know about
been
it.
used.
Yeah. Thanks.
Can I ask a question while I have the microphone?
Sure, go ahead.
Okay. It's a question for Jim. Do you find you use the diffuser a lot in your nozzles?
Yeah, quite often,
Yeah.
actually. It's kind of the go-to setup, beginning setup.
Yeah.
So I can tell very quickly if it's going to work with the diffuser. If it doesn't, then I'll remove it and go to different orifices or different nozzles. But usually it's the first thing that goes on, so I can kind of see what's going on. Yeah.
I have to say, I also used the diffuser, and for me it was especially the back of the sculpture. It had another surface. It was more pitted, larger pits. And for me there, the diffuser worked better because it made the particles smaller, I guess, and it could penetrate better into these pits. So for me, that area, it was really hard to remove, but when I used the diffuser, I really got more success. So.
And did you find, this question for all three of you, I guess, that I believe the more square nozzles have a much more even particle distribution than the round nozzles, for example. Is that something you've noticed? So the middle is supposed to be sharper on a round nozzle, or?
All of our nozzles are round. Now there's one that's fluted, so it basically starts at a 6 millimeter and widens up to a 12. So we found that to be a fairly gentle nozzle because it actually is spreading out the media. One of them is a straight number 6, and we usually find that that's the most aggressive. But we don't have any square. The fan one that you see everyone use, the blade, quote unquote, they say is the least gentle, but like I said, in some cases it's really aggressive, so it's just a matter of trial and error.
Yeah, I think that's what I call square. The
long
is
fan.
rectangular.
Yeah, what that's meant to do is basically spread those particles out in a line versus a round disc.
Joe had a question?
So back to the lead abatement, it sounds like a laser would be more appropriate for the window cleaning job, because at least our laser has a built-in HEPA system. It's a double HEPA system, and it's been thoroughly tested by the Navy, Air Force as far as operator exposure. But I do notice in a lot of the videos and the presentations that there's a lack of PPE or respirators being worn. We kind of went through this in the laser field, that it seems like an amazing thing. The ablation happens, the material kind of disappears, and you don't really think about it. It's just, I'm concerned about sort of operator safety at that point and exposure to things that we don't really know what's on the surface and what we're blowing off. Because there is a residue that's obviously the material that you're ablating or removing from the surface has to go somewhere. And they do make a water jet system that is essentially a containment that goes around the end of the water jet that it vacuums and evacuates the water. I would imagine a similar thing can be used. The downside is it's kind of hard to see what is happening on the surface, but it would be nice to see some sort of a extraction system hooked up to the system.
Yeah, yeah.
Thank you for the comment, Joe. Anybody else have a question? I have a question for everybody that's up here on the panel. So we've got cleaning outdoors in sunny LA. We've got cleaning outdoors in wintry Ohio. We've got cleaning outdoors in Utah. How does that affect the experience with using large-scale solid CO2?
Greatly. The Charleston, West Virginia one that I showed, it was about 105 degrees outside with about 90% humidity. And you get clogging on the machine, you'll get moisture problems. Whereas if it's dry, you have none of that. So especially I found the relative humidity is the big deal. If you're in a dry area, it's usually not an issue. That being said, when I was doing the aluminum sculptures, and speaking of safety, they're all grounded. You have to ground everything because you're creating a static charge. And I got shocked so hard doing the aluminum sculptures, I thought I was being defibrillated a few times. And it's because aluminum, for some reason, builds up such a static that you have to kind of discharge that. Otherwise, you will get shocked, and it's not pleasant.
Any thoughts on grounding?
Yes, they should have a ground strap with it.
They do. The machine actually grounds to the work. I didn't show it, but the machine actually grounds to the work that you're working on. That being said, the potential for grounding was overcome by the static, and you are a very attractive ground. So what I found from an operator standpoint is you tap the nozzle to the unit to the work every now and then, and that discharges the static. So every now and then, like if you watch me in the demo, I'll be blasting, I'll reach over and just tap it to discharge the static.
Can I add to that?
Sure.
Yeah, even with CO2 snow, you could get charge. On the units used for telescopes, I'm supposed to supply a grounding strap with it. I forgot it on the last unit. I got a nasty call pretty soon. And even with CO2 snow, not for the telescopes, normal situations, if you have an inconsistent sample where there's insulators and conductors, you can see sparks. So CO2 snow, a lot less flow, a lot lower velocities, has the same, and pellets are much worse. If they sent a unit without a grounding strap, there could be trouble.
Yeah, absolutely. The large fiberglass sculpture that I worked on, obviously you can't ground that. So you just have to take a break every now and then and let the static kind of dissipate, because that's where it gets dangerous, is if you're dealing with something that's not groundable.
Great.
I just want to go back to the humidity real quickly, because like one day we had also a humid day in LA, a rainy day. Of course, we planned it.
No way.
Yes. And, so there was the nozzle that completely got clogged for a little while. So you got really a buildup of ice in your nozzle, on your nozzle, and if it rains, it really clogs it up. So you really have to stop and wait until it really evaporates. And so you really have a clogging. So you have to take that into account.
That's good to know. I know it's a really big, the environmentals are a really big issue with the snow, so I was curious for the larger scale. We had another question right here in the center.
Hi. I was wondering, most of the talks have to do with outdoor sculpture and using the machine outside, and I know there were a couple mentions of setting up indoors in the spray booth, but I'm wondering if any of you can speak to any experience with using this type of setup indoors, not in a spray booth. What kind of ventilation issues did you encounter, and how did you mitigate them?
I've used the i3 outside of the spray booth, just in our lab, but we have elephant trunk extraction. So, when I was doing the gilt bronze mounts, kind of used that, but then also kind of wearing a respirator and such. But you do need extraction if you can, use something portable or have something in your lab.
I think for the larger machines, the problem is that you have your compressor, and like I wouldn't put that indoors most of the time.
Put that indoors.
So you're already limited by that. It's not really a tool. I think the pellet blasting is not really something you can use indoors.
If you did manage to run the hoses indoors, you would really have to monitor your CO2 levels because it will displace oxygen at a very rapid rate, especially if you're blasting a lot of media with high pressure.
And I would second what Jim says, because, you know, it's not just that you're using CO2, it's the rate. So if you're delivering 100 pounds per hour or whatever, you've got a lot of rate versus, you know, a few ounces per minute with a snow system. It's a big difference. So a monitor is really important.
So the CO2 buildup would have been probably a lot more in your scenarios than how I was using with the i3, but. Oh.
3% CO2 in a room will kill you in a half an hour. 1% probably can cause physiological damage in several hours. So have a CO2 meter, and there's inexpensive ones available with alarms.
Yeah, this becomes very important if you're dealing, for myself, in the interior of a sculpture. So if I'm inside of a Tony Smith, I'm in a confined space. So this is just something to be very aware of, yeah.
So I would imagine you're using supplied air then? So you can use it indoors if you're protected and have a supply of fresh air, meaning a mask or something that...
Yeah, if you had a supplied air system and you're dealing like in an internal sculpture or something, you'd be fine, yeah. But I would still have a monitor just in case, just like you do in blasting, you have a monitor in there to make sure.
And I also think what Robert was really getting to is actually extraction of CO2 from the area is also desirable because of the buildup rather than just displacement. So.
But just to clarify, I have used it in the lab with an elephant trunk and some extraction, and I always use a CO2 meter close to me, and it will start to build up around you, and then you stop. So, I mean, it is something that you need to monitor.
I have a comment, not a question.
Sure.
I'm sorry for all of it's exciting. I just wanted to thank you for this. To me, it's, I think, the newest, or it's been around, but it offers environmentally safe alternatives to chemical stripping, to abrasive blasting, all the things we hate about our job of dealing with outdoor monuments and sculptures. And I thank you for putting the conference on. So it's really exciting. And great papers. Thank you.
I have one last question to solicit before I wrap it up. And this is probably, I guess, both to Julie and Jim. The dollars and cents, has it been worth the cost of investment in equipment?
Our equipment paid for itself in 3 days.
Yes.
There you have
I
it.
won.
All right, thank you very much. I'm going to turn it back over to wrap up.